Hi guys, Sauce here. This is a lesson on repeat decay. Previously we talked about repeat growth. Let's remind ourselves what we mean by that. Repeat growth, for example, means that we could increase the amount of something. In the previous example, we increased the amount of money that we had by 10%. A 10% increase we can think of as taking 110% of our starting amount. Mathematically, what we do to take 110% of something, or to increase it by 10%, we multiply by the decimal equivalent of 110%, which is 1.10. We've done that in the past, and this is an example of how to think of increasing the quantity of something. And if we wanted to continue to increase by 10%, we would continue to multiply by 1.10. And after it grew, we'd multiply again. And we can keep doing that. Let's talk about the inverse of that situation, which is repeat decay. Decay in math is a word that we use to mean the opposite of growth, something that is getting less and less in number as time goes by. And to compare it to growth, we can think of, instead of increasing by 10%, we're decreasing by 10%. So we can think of decay as a 10% decrease. Or taking 90% of what we had before to get a new, lesser amount. Increasing by 10%, we can think of as taking 110% of it. Decreasing by 10% means we take 90%. That's 10% less than 100%. And how we accomplish that mathematically is we multiply by the decimal equivalent of 90%. We're going to multiply by 0.90 to decay, to get less. In a previous example, we used a table in order to show the process of repeated decay. We're going to do that again. We're going to think of this as $100 that we have invested, but our investment is poor, we're losing money. So we're going to lose some of our starting amount. It's going to decay. And we're going to start at year 0 in this table. Year 0 means no time has passed. We're going to use this column of years to track how many years have passed as we repeatedly decayed this amount of money. But in the very beginning, no time has passed. We call that year 0. So we're going to decrease by 10%. We get 100% minus 10%, which is 90%, the number that we're going to use in the math to find out how much we have left. So this is a problem in which we need to take 90% of the $100. And it will be the result of decreasing by 10% will be placed in this column. Mathematically, this is a percent of a number is something that we're going to find out. Mathematically, we're going to translate that to multiplying the decimal equivalent of 90% times the amount of money that we currently have, 100. We can ask a calculator to do that for us. 0.9 times 100 is equal to the remaining amount of money after it has decayed, $90. We had decayed just once, but if we're going to repeat this process, then we're going to take the ending amount after 1 year, and we're going to have a new beginning after 1 year has passed of $90. We're going to decrease this $90 by 10% again. And it's the same mathematics. We're going to take 90% of our remaining $90. Translating that into math, I'm going to multiply the decimal equivalent of 90%, which is 0.90. And this time, instead of this dot for multiplication like before, because I have a decimal point and I'm using the dot for multiplication, it can get kind of confusing. We're using the same symbol in two different ways. I'm going to just use the parentheses for multiplication. So I'm showing here a different way of what I've done before, 0.90 times 90 in parentheses. I'm going to look to a calculator to take care of that math for me. 0.9 times $90 gives us $81. This is at the end of 2 years. So if 2 years have passed and I wanted to find how much money is going to be after 3 years, I'm going to fill out a new line in this table. 2 years have passed. At the beginning of that 2 years, I have $81. I'm going to take 90% of $81, show the math as 0.9 times 81. Notice that I left off this leading zero because I don't need to put any zeros after the last decimal place. If I don't, I could, I did before, but I don't need to. So I'm showing this as 0.9 times 81, and I go to a calculator once more, 0.9 times 81, and the calculator gives me 72.9, which is the amount of money after my original $100 decayed by 10% 3 times. Now, just like the problem in the past with the increase, we can see that every time that we decayed by 10%, we multiplied by 0.9. This repeated multiplication by 0.9 can be expressed as a power 0.9 to the third, because a power communicates the idea that we are repeatedly multiplying the base times itself. If we start with $100 and multiply by the power 0.9 to the third, this math is the same as the math that we did in the table, and it will give the same result in the end, 72.9 dollars.